Okay, guys, so this is lesson for 9.1. Totally new chapter. We're starting out with some statistics and stuff. You're eventually going to have a data project that you're going to need to know a lot of these things from this lesson for your data project that you'll be doing right after Easter. So today we're going to identify what a statistical question is. If you guys remember, we talked about that a tiny bit right before your IAR test. You're going to create a dot plot, and within that dot plot, it'll identify some clusters, peaks, and gaps. So make sure you have your notes ready to follow along here. We've got two definitions you guys are going to fill out. Statistics is the science of collecting, organizing, analyzing, and interpreting data. So statistics are gathered a lot of times with sports, grades. A lot of businesses gather statistics about their sales, their expenses, things like that. So it's used a lot in a lot of different areas of life. And our other vocab word for today is statistical question, which is what we had talked about for IAR. So a statistical question is just a question for which you do not expect to get a single answer. That's the key phrase here. You don't expect a single answer. So you're interested in the variety of the answers. Variety means there's going to be a bunch of different ones. And distribution just kind of means like what that looks like when you graph it out. So we'll talk more about statistical questions in a minute. If you need a second to finish writing these down, go ahead and pause, but I'm going to keep moving on. You don't need to work with a partner here. Obviously, you're watching a video, so a little different from the directions that you see here. But you're going to answer each question below on your own, and then you'll compare answers with me here in a minute. I'll tell you what my answers are. So read over those questions there, 1, 2, 3, 4, 5, 6. And just jot in an answer next to it. There might be one or two that you don't know. That's okay. Take your best guess, okay? So go ahead and pause so that you have time to answer those questions. All right, now that you've answered questions 1 through 6, let's go over some answers together. So what's your shoe size? My shoe size is 8.5. More like 9.5 when it's running shoes. You guys might know how that is. Sometimes different shoes, different sizes, right? But I'll bet you have a different shoe size. Maybe some of you have the same shoe size as me, but most of you probably have a different shoe size, okay? We would expect a variety of answers here. Not everyone has the same size feet and the same size shoe. Number 2, how many states are there in the United States? Hopefully you said 50. We should all say that because that's the one correct answer to that question. Number 3, how many brothers and sisters do you have? I only have one brother. I'm sure some of you also only have one sibling, but a lot of you probably have many more siblings than I do, so we would expect a variety of answers there. How many U.S. presidents have been in office? You might not have known this one. The correct answer here is 44. But again, there's only one answer to that question. We've only had a certain number of presidents, so we don't all have a different answer to that, or if we do, it's just because we didn't know the correct answer. Number 5, what's your favorite type of movie? My favorite type is comedy. But again, I'll bet every single person that watches this video doesn't also love comedies. There's a variety of answers we would expect here. And how tall are you? Well, I'm 5'8", but again, I'm guessing there's a lot of you that are, for the most part, in 6th grade, shorter than that, right? There might be a few of you that are the same height as me. So look at part B here. It says, some of the questions above are considered statistical questions. Which ones do you think they are and why? Well, that's the definition you just wrote down on the last page. We look back at it for a second here. Remember, statistical questions are ones for which you do not expect a single answer. You're expecting to get a variety of answers, and that's what you're interested in. So using the numbers here, which of these do you think are statistical questions? Pause and take a minute to write that down. All right, hopefully you said that you thought the statistical questions were 1, 3, 5, and 6. Those are the ones that we should get a variety of answers for. We shouldn't get a variety of answers for 2 and for 4 because those have one correct answer. That's like a question I could put on a test and mark you either right or wrong. There's not a variety of correct answers. Part C says some of the questions above have numerical answers. Which ones do you think they are? So if you notice, they all have numerical answers except for number 5, right? So everything except for 5. I brought that up because on your project, you're going to have to come up with a statistical question of your own that also has numerical answers. So while 5 is a statistical question, we would expect to get a variety of answers. It's not numerical, okay? So it's not one that we can do a lot of the graphing and data analysis that we're going to learn in this chapter. So you wouldn't be able to ask a question like number 5 on your data project. You wouldn't be able to use 4 or 2 because those aren't statistical questions. So questions like 1, 3, or 6 would be good questions to ask on your project, which we'll talk about more later this week, okay? All right, there's lots of ways to analyze and present data. We're going to talk about box and whisker plots in this chapter. You've learned bar graphs before, pie charts. These are all different ways of analyzing data and showing your results. Another way to analyze and present data is something called a dot plot. In some books, call it a line plot. I've seen it referred to as both in different math textbooks. Our book, though, calls it a dot plot. So a dot plot uses a number line, and it shows the number of times that a piece of data occurs in the set. It's kind of like tallying, okay? So think about if I were to look at data and tally up, okay, how many 13s do I have? How many 13.2s? How many 13.4s? I could use tally marks. This is just a different way of basically tallying the data, a nice visual way to represent how many I have of each number in this case. It helps show the spread, like how far apart they are, and distribution, like where it's clustered in the data set. So this is an example of a dot plot, totally done. It's got a title here you can see, so that we know what is this data talking about. Just random numbers otherwise isn't very helpful for us. We need a title so that we know what do those numbers represent. So these are 7th grade girls' times in the 100-meter dash. You guys know I'm a track coach, so that's something that's interesting to me. So if you look at this dot plot, let's see if you guys kind of understand how to read it. How many girls ran the 100-meter dash in 13.6 seconds? Take a second to think about that. How many girls ran it in 13.6 seconds? Hopefully you were thinking 2, because there are 1, 2 dots above 13.6, okay? I'm going to ask you another question. 4 girls ran a certain time on this data plot. There's only one time where there's exactly 4 girls that ran this time. What time is that? What time was run by 4 7th grade girls? Hopefully you said this one, and hopefully you knew that that was 13.9, because I see this is 13.8, this is 14.0, so in between must be 13.9, okay? I'm going to erase that for a minute here so we can see the dot plot with all my drawings on there. Okay. So there's some different features of dot plots that we want to talk about here. You can have gaps, which means that there's parts of the dot plot where there is no data. So we have a tiny little gap here. No one has a time of 13.1. We have peaks. I'll bet you could easily guess what a peak is. That would be data that has the most number of girls in this case, the most number of dots above it. Okay, so your peak here is at 13.8. And we can also have clusters. That means like where a lot of the data is centered around together. I would call the cluster right about here. So you've got 5 at 13.8, 4 at 13.9, 3 at 13.7, 2 at 13.6. So that would be a cluster. Most of the data is in this section here. And then you've got a few times over here and a gap and then 13.0 over there. All right? So that's your dot plot. It has a title. You have the number line with labeled times. You can see they skipped every other one here, and that's fine. And then you have your dots above to indicate how many there are of each of those times in this case. What observations can you make about the data? I think I kind of just did this on the last page, actually. Yeah, I did. So we can skip this page. I forgot I had that page there. So let's take a look at doing a dot plot ourselves. So it says you conduct a science experiment on house mice. Your teacher asks you, what's the weight of a mouse? Is this a statistical question? Explain. So what's the weight of a mouse? Is that a statistical question? In other words, is that a question where you expect to get a variety of answers? Hopefully you're thinking, yes. Much like people, not all mice are going to weigh the same, right? That's my explanation, that all mice are going to weigh something different, okay? And I can tell by looking at the table down here where I have different weights of mice, those are clearly not all the same. We're going to create a dot plot using this weight data here for the mice. When you create a dot plot, first you're going to want to find out by looking at your data, what's your lowest data value? What's your lowest number? Okay. So take a look at that table there for a minute. See if you can figure out what's the lowest weight we have. And hopefully you said 18. You also want to figure out what's your highest number. And we're basically doing this so we know what's the beginning and ending of our number line. Okay, so we know how long to draw it. We can kind of figure out how we want to count by. So take a minute, look for what's your highest weight on there. And hopefully you said 28. So after you identify those two things, then you're going to make your number line. Okay? And you're going to want to decide, what do I want to count by? Like in this last number line, the 7th grade girls 100-meter dash times, they really are counting by tenths, right? Because this would be 0.1, 0.2, 0.3, 0.4. They only labeled every other one, but they have a tick mark for every single tenth. That made sense there because if they just did 13 and 14, they wouldn't have space to put in all their dots, or it would be really clustered together and hard to understand. So you have to look at your data and decide what makes sense for your data. So going from 18 to 28, I would say we could just count by one. So I could go 18, 19, 20, and that should do a good number line for us. I'm going to leave some space up above here. I don't want to draw my number line right here because then I won't have any room for the dots. So go down, pretty far here. Give yourself some space. Draw yourself a number line. Remember, number lines have arrows on either end. We're going to start with 18 because that's our lowest number. And then counting by ones, go up to 28. So go ahead and do this as well while I'm doing it. I made my number line a little too long. That's okay. We'll just fix it. You can do the same if you made it too long or too short. Pretty easy to fix when you're using a pencil. So now what you want to do is just work your way through the table here. Start with your lowest number. And I would cross these out as I go. It's going to be really confusing if you don't. So I'm only going to look right now for 18. So I'm going to look and go, nope, 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 nope. Oh, but this is an 18. So 1, 2, and that's it. So there are two 18s, so I want 2 dots above my 18. Now I'm going to do the same thing with 19. 1, 2, 3. There's 3 19s. So you can see how I just move across in an orderly fashion, and I'm counting out loud as I go. You can count in your head, obviously, but for here I need to count out loud so you guys can hear me doing it. But that's, I think, the most organized way to do this so you don't miss anything. You'd also want to know how many total pieces of data you have so you can check at the end, is that how many dots I have? So I have 4 across, 5 down here, so now I have 20 weights. So I know when I'm done, I should have 20 dots, and if I don't, I miss something. All right, so 20 is my next one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and that's why we wanted space for our dots there. All right, 21. 1, 2, 3, 4. 22. Oh, there's one down there. 23. There's one. Now there's hardly any numbers left to check. 24. Nope, no 24. No 25. No 26. I see 2 27s. And I see a 28. So if I count my dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Good, I have all my dots. So where is the peak in our data of house mice weights here? Hopefully you said that the peak is 20. There's a cluster from 18 to 21, I would say. And there's a gap from 24 to 26. So on your homework, they're going to ask you to create a dot plot and then also identify these 3 things. So this is how you can write that out. Explain where the peak is, where the cluster is, and where the gap is. Will there always be one of these things? There might not necessarily be a gap. There might not be a cluster. It might be very evenly distributed. It There could be more than one peak, so I might have had like one that's 6 high and another one that's 6 high over here, so you could list out multiple peaks, or there might be ones that are real close together, and then that would still be multiple peaks, okay? But if there's just one that's the highest, then that's your one peak. All right, let's look at another example. Table of ages of people who retired early. Create a dot plot and identify clusters, peaks, and gaps. So you guys try this one on your own, pause, and then start it up again when you're ready for me to show it to you. All right, so remember, identify your lowest and your highest numbers so you know how to make your number line here. My lowest is 56, and my highest is 64. So I'm still just going to count my ones. I won't show crossing off in the table this time because that'll take a little extra time, and you guys hopefully got that down. 59, 60, 61, 62, 63, 64. Okay, so you should have 1 dot above 56, 2 dots above 58, 3 above 59, 1, 2, 3, 4, 5 above 60, 3 above 61, 1 above 62, and 1 above 64. So in terms of listing off your peaks, your clusters, and your gaps, you've got one peak at 60. You have a cluster from 58 to 61. And you've got small little gaps, I would just say at, because there's not like a range this time, at 57 and 63. Okay, so know people who retired at those particular ages. All right, one last one for you guys to try. Not really anything different, just making sure you got it. So go ahead, pause it, try it on your own, and we'll check back in a second. All right, if you identified here, your data basically goes from 1 to 10. 1 is your lowest, 10 is your highest. So you want a number line that goes from 1 to 10. You should have 3 dots above 1, 2 above 2, 1 above 4, 2 above 5, 3 above 6, 2 above 8, 2 above 9, and 1 above 10. So in terms of our peak clusters and gaps, this one has 2 peaks, so peaks, plural, at 1 and 6. You also have some clusters, I would say. You have a cluster at 1 to 2, at 4 to 6, and at 8 to 10. And then your gaps are at 3 and 7. All right, hopefully that gives you guys a good idea of how to do dot plots and statistical questions. So the substitute will have you work on your homework when you're done with your notes.